This mathematics tutorial is a supplement for 8th grade Open Up Resources Illustrative Mathematics, Unit 7, Lesson 8, Number 3, Multiplying Exponents. This example shows the multiplication of exponents. You'll notice an exponent on the outside of the parentheses. This exponent goes with each of the bases on the inside of the parentheses. For example, 3 to the power of 3 times 5 to the power of 3. And you noticed once I moved that exponent to the bases on the inside of the parentheses, I was able to remove the parentheses. And since this expression is only dealing with multiplication, we can rearrange the order of the terms. This 5 is actually 5 to the power of 1. When I combine 5 to the power of 1 with 5 to the power of 3, it becomes 5 to the power of 4. I combined those two terms for a reason. And that reason is now I can multiply 5 to the 4th power times 2 to the 4th power. Again, I can rearrange the terms to make this easier for me. I know that 2 to the 4th power times 5 to the 4th power is 10 to the 4th power. To illustrate why, I can take their common factor, the power of 4, and put it outside the parentheses. And 2 times 5 all to the power of 4 is equivalent to 10 to the power of 4. Now the expression looks a little bit different. 3 to the power of 3 times 10 to the power of 4. Let's take a quick look to see how we got to this point. Three times 3 times 3 equals 27, and 10 times 10 times 10 times 10 equals 10,000, and 27 times 10,000 equals 270,000. Let's try another expression. This example involves multiplying exponents and dividing by a term with an exponent. First, I'll use the distributive property to distribute the exponents from outside the parentheses to the terms that are inside the parentheses. And after completing that step, I can remove the parentheses altogether. I'm doing this so I can reorder the terms. Notice that the divisor, or the denominator, is 3 to the power of 2. Now look at the dividend, or the numerator, and you'll also notice a 3 to the power of 2. That's the same as 3 to the power of 2 divided by 3 to the power of 2, which is 1. Essentially, they've canceled each other out. I notice terms with the base of 5 and 2. I like that because 5 times 2 equals 10. 5 to the power of 2 times 2 to the power of 2 is the same as 5 times 2 all to the power of 2. Which of the remaining pair of terms would you match with this 5 to the power of 2 to make it easier for you? I would choose the term that has 2 as its base because 5 times 2 equals 10, and that makes it easier for me. But I am going to add just a bit of a challenge. I'm going to take that exponent that's attached to the 5 inside the parentheses, and I'm going to move it outside of the parentheses. Look at the two remaining terms at the top of the screen, 2 to the 3rd power and 3 to the 2nd power. It looks like 3 to the 2nd power is the only term that I can choose to use with the 5 inside the set of the parentheses because the exponent on the outside of the parentheses is a 2. But since I'd like to use the term with a base of 2, watch what I do. Let me show you that again. I'm taking the 2 to the power of 3 and I'm changing it to 2 to the power of 2 times 2 to the power of 1. I leave 2 to the power of 1 up there with 3 to the power of 2. So now inside the parentheses I have 5 times 2 all to the power of 2. Let's look again. 2 to the power of 3 becomes 2 to the power of 2 times 2 to the power of 1. And I take the 2 to the power of 2 and I insert it into the parentheses. Now we have 5 times 2 all to the power of 2. 5 times 2 is 10, and 10 to the second power is 100. 100 times 100 is 10,000. 3 to the second power, or 3 times 3, is 9. 2 times 9 is 18. I'll let you take it from here, but essentially, it's 10,000 times 18 times 1 divided by 1. Hopefully your answer is 180,000.